Maybe you've mastered the technical details of React and are wondering where to go next, or maybe you're just looking to start thinking about your applications at a higher level. Whatever the case, learning the basics of software architecture may well be the next step in your software development career. A knowledge of software architecture enables you to not only make your applications work, it also allows you to keep your applications maintainable and performant for the foreseeable future, as well as make sure they fulfill all the necessary requirements and constraints. Join me in my course to learn software architecture with React and see how to think about your React applications on a whole other level. To get the most out of this course, there are a few things that it would be helpful for you to know. The first skill that you should have is a basic knowledge of web development with React. Now, please don't take this to mean that you have to be a React expert. You don't. But at the very least, it would be great for you to have experience with creating and managing React components, routing in React, and React hooks. If you don't have these skills yet, I highly recommend that you take my course on full stack development with React, where we see how each of these things works in the context of a full stack React application. Really, it would be helpful for you, it would be helpful for you to have a basic knowledge of how full stack development works in general. It would be great if you already know the basic roles of the front end and back end, as well as how these pieces fit together and communicate with each other via network requests. If you have these things, Okay, we're going to get started here by talking about what software architecture is in the first place. So in order to define what software architecture is, let's think about architecture as the word is normally used, which is applied to buildings. When we talk about the architecture of a building, we're generally referring to the overall structure and large-scale design of that building. Whereas interior design would be more of the details inside the building. So in a similar way, when we talk about software architecture, we're talking about studying the larger structure and organization as well as patterns of our development project. And we're particularly concerned with these things with regards to how they impact developer productivity over time. Now, this last part is where software architecture and regular architecture diverge a little bit. I'll get to that in just a second. First, let's take a look at the goals of both architecture and software architecture. With architecture, the goal, in a very general sense, is to design a building that fits the constraints and required uses. So right here we have constraints on one hand, which are things that are challenging about the project, things like budgets and zoning restrictions, and we also have the required uses. That's what the people who are building this structure need it to do. Now, on the same token, in software architecture, our goals are pretty much the same. We want to design software that fits the constraints and required uses. And just like with regular architecture, the constraints are usually things like budget, and the required uses are what people are designing that software to do in the first place. So here's where we get to the differences between architecture and software architecture. With architecture, once we've built that building, once construction is completed, it's going to remain fairly static over time. Yes, we'll have to renovate it every once in a while, and there will be ongoing maintenance with the plumbing, the electricity, etc. But for the most part, we're not going to make any drastic changes to it. With software architecture, on the other hand, that thing that we design is going to be constantly changing throughout its lifetime. In other words, you're never going to get to that point where everybody's happy with it and no one wants to add any more features. Trust me, managers and other stakeholders are always going to want to add other features. So what this means is that we have to design our software in a way that it can be easily changed over time. So you might be wondering where React fits into this, right? I haven't even mentioned React yet. And that's because, in theory, software architecture is meant to be independent of any of the given technologies that are used, right? This allows us to design our programs without saying, okay, we're going to use MongoDB, or okay, we're going to use React, right? It keeps it more flexible in case you want to change your technologies down the road. However, since this really is more of a practical course, and I have very little interest in doing a theoretical course about this, what we're going to be doing is looking at a lot of concrete examples that involve React to demonstrate some of the larger architectural concerns that usually come up in React applications. A little more specifically, we're going to be covering 5 main things with React applications. We're going to start off by looking at server-side rendering. Some of you may be familiar with what this is, some of you may not. We'll talk about that shortly. The next thing we're going to talk about is state management. That is, how do we effectively manage the data that our application deals with? After that, we're going to discuss data loading. What is the proper relationship between our front end and back end, and how do they communicate most effectively, especially in the context of server-side rendering, which we'll talk about. Next up, we're going to talk about code splitting, which is how do we effectively deliver the code that we've written to our clients. And last but not least, we're going to talk about project organization. How do we organize our code in such a way that it remains easy for developers to work with? Well, those are the main topics we're going to be talking about here. Let's get started. Okay, so the first architectural topic that we're going to talk about in this course is server-side rendering. Now, many of you may know what server-side rendering is already. I'll define it in just a second for those of you who don't. But server-side rendering is an extremely important topic for many production-grade applications. And it can also considerably complicate the architecture of our application, which is why we're going to take a look at it here. So first of all, let's talk about what server-side rendering is. In the normal flow of a React application, here's what happens. The client's browser makes a request to the server and loads the index.html file, which doesn't really contain anything. It's basically blank at that point. That index.html file then tells the browser to load our React scripts, which are the ones that actually render all of the HTML elements into the page. However, with server-side rendering, the server is the one that takes care of running our React scripts and rendering all of our elements. We'll see what this looks like in code very shortly, but first let's talk about some of the comparisons between client-side rendering and server-side rendering. So, as we said, client-side rendering renders the app to HTML in the user's browser. So the user's browser is essentially the one that's doing all the work there. In server-side rendering, however, the server is the one that's doing most of the work, and then it simply sends that finished HTML document to the client. Right? The client doesn't really have to do very much in that case. As far as the order in which things happen between client-side rendering and server-side rendering, with client-side rendering, the process is pretty complicated. First, as I've said, we have to load the index.html file from the server. Then that index.html file tells the browser to load the JS bundle from the server that contains all of our React code. The browser will then run that bundle, right, rendering all of our elements. It will display our app, and then it will still have to load the data from the server. So you can see we've got quite a few round trips here. We've got at least 3 for loading index.html, loading the JS bundle, and loading the data. With server-side rendering, this process is quite a bit simpler, actually. We start off with the server rendering the app, basically running our React scripts, converting it to HTML. It then loads the data, which is much easier since we're on the server. And after that, it will create an HTML document, which it will send directly to the client side. So as far as the pros and cons of each of these, with client-side rendering, there's generally less strain on the server, right? The user's browser is the one that's doing all of the work of rendering. However, especially in cases where users have a slow internet connection or where your users are geographically very far away from you, for example, if your servers are in New York and your users are in Australia, having these multiple round trips just to load the index.html, the JS bundle, and the data can really lead to a very poor user experience. However, with server-side rendering, since there's only one round trip, this can lead to a drastically improved user experience, and it can also be better for SEO. However, obviously there's going to be more strain on the server since the server is the one doing all the work. So if you have a lot of users during a big sale or something like that, you're going to want to make sure your server's powerful enough to handle that. Okay, so now that we've learned a lot of the background behind server-side rendering and how it works, what we're going to do is see what it looks like in the context of a full-stack React application. So to get started here, you're going to want to copy the starting state of the exercise files, which contain basically just a stripped-down version of the Create React App starting app. So once you've got that, you're going to want to run npm install in that folder, and that will install all of the dependencies for the project. And once you've done that, what we're going to do next is set up a very simple blog application, which will give us a good starting point for adding server-side rendering. So to get started, let's create a new folder in here, which we will call Pages. And we're going to create 3 different pages for our app. None of them is going to be very complex. We're just going to say home.js, which will be the home page. We'll have about.js, which will be the about page. And we'll have articles.js, which will be the articles page. And now that we've done that, let's just implement some very, very simple JSX for each of these. What we're going to do is say export const home. And the JSX for this, we're just going to have an h1 heading that says home. And for purposes that I'll explain once we actually start rendering this thing on the server, we are going to need to say import React from React at the top. This is something that Create React App has made it possible for us not to do when we're running it locally, but when we're rendering it on the server, just because of how React works behind the scenes, we're going to need to have this import at the top of any file where we use JSX. So that's our home component. Let's just copy this and paste it into about and articles, and these are going to be pretty much the same thing. We just need to change the component name and the component's heading here. And we'll do the same for our articles page. We'll say articles and articles. Okay, so the next thing we're going to do is just add basic routes for each of these. So here's what that's going to look like. We're going to start off by installing the React Router DOM package. Many of you are already familiar with React Router DOM. We're just going to install that. And while that's installing, let's head over to our app component and add routes for each of these. So first of all, we're going to also have to import React at the top of our app.js file. We're going to say import React from React. That'll allow us to render this thing on the server once we have one. And let's create some routes here. We're going to start off by importing some components from the React Router DOM package. So we'll say import browser router, switch, and route, as well as link from React Router DOM. And then we're going to set that all up by wrapping everything inside a browser router, including the heading here. We're going to have a switch, and inside that switch, we're going to define all of our routes. So first, we're going to have to import our home, about, and articles components. I'm just going to do that like this. About, import articles, and these are all from the pages directory. And now that we have those, let's define our routes. We're going to have the first route be for our home component. The path for this route is going to be just /, and we're going to say that it's exact since we only want this to show up when it really is the home route. Under that, we're going to have route with a path of /about. That'll be for our about page, of course. And then we'll have another route with the path of articles, which, as you may have guessed, is going to display our articles page. So now that we have all of our pages, the last thing we're going to do is just add a basic nav bar at the top here for each of our pages so that we can get around a little easier. So we're just going to have an unordered list here with several list items, each of which will contain a link to the respective pages. So we'll have a link to our home page here, which will say home. We're going to have a link to our about page here, which will say about. And we're going to have a link to our articles page, which will say articles. Okay, so let's run our application locally just to make sure everything works. And this is not being server-side rendered right now. That's what we'll add in just a minute here. And let's just make sure our routes work. And that's it. We should be good to go to add server-side rendering to our application. Okay, so now that we have our very simple blog application, what we're going to do is start adding some server-side rendering to it. So the first step in all of this is that we have to create a server file that will actually run, listen for requests, and render and serve our app. So let's create a new file in the outermost directory of our project here, and we're going to call it server.js. Now, This is going to be a basic Express server, and we'll want to write it in the same JavaScript syntax that we write our front end in, right? Since it's going to be essentially running our front end code. So in order to do both of those things, we need to install a few packages. The first thing we're going to do is say npm install --save-dev, and we're going to install some packages from Babel that will basically take the modern code that we write, such as in React as well as on the server itself, and basically convert that into something that Node.js will be able to run. So we're going to say npm install save-dev. We're going to install a few packages here. The first one's going to be at babel/core, then at babel/node, at babel/preset-env, and at babel/preset-react. And we're also going to install a node daemon to take care of running and restarting our server when we make changes. So let's hit enter and install all of those packages. And once you've installed those, we're also going to want to install the Express package, which we can use to build a basic server. And there we go. So let's get started creating our server. We're going to start off, of course, by importing Express, which we'll be using to create our server endpoints. And we're also going to import React since we'll be using JSX inside our server. After that, we're also going to import something called render-to-string from React DOM/server. This will do the actual rendering of our app, as you'll see. And that's all we'll need for now. So let's create our server. We're going to say const app equals express. And then we're going to say app.get. And the path that we're going to specify is going to be / with an asterisk. Basically, that means that this route will respond to any GET requests on any path, which is exactly what we want, since basically what we want to do is no matter what path the user requests, we want to send them back this HTML file, which is going to be our rendered React app. So the callback here is just going to be a standard Express callback. And inside of here, what we're going to do is say const React app equals render to string. And this render to string is a function that we can pass JSX to, and it will basically take that and render it into actual HTML. Okay, so just to get started here, let's define a basic h1 heading, and we'll say something like hello from the server side. All right. So what this line is going to do is take this JSX, convert it into an actual HTML string, and we're going to send that HTML string back to the client. Now the way we do that is by saying return response.send, and we're just going to define a very basic HTML string in here. We're going to say HTML. We're going to define our body here. And inside there, we're going to say div id equals root, just like the usual div that we render our React app into. And inside of there, we're going to insert the React app string. So we're going to say React app. Just like that. Okay, so that's our server endpoint that will take care of rendering the JSX and sending it back to the client. What we're going to do now is just tell our server to listen on port 8080. And we'll say console.log server is listening on port 8080. And that's all for our server code for now. One last thing that we're going to have to do before we'll actually be able to run this code is define a Babel RC file. This will basically tell Babel, which again we're going to be using to run our server and transpile code, it's going to tell it what presets it will need to use in order to make sense of our code. So let's create a file in here called babelrc. This is just going to be a simple JSON object that we put in here with the key presets and a value, which is going to be an array that contains two things. The first is going to be babel/preset-env. That's just the standard preset for converting newer JavaScript syntax into older JavaScript syntax. And then we're going to add another preset called @babel/preset-react. Basically, this preset will take care of transpiling the JSX into actual JavaScript code. JSX isn't typically something that Node.js can parse without a little help. So now that we have our Babel RC, what we're going to do is run our application. And to do that, we're just going to open up a terminal and say npx babel-node server.js. And we should see that it says server is listening on port 8080. So now if we go up here and paste localhost 8080, we should see the message hello from the server side. And this was rendered from JSX on the server and sent back to the client side. We can actually see this if we open up our inspector window, go to the network tab. We might have to hit refresh so that we can see the actual requests. And if you click on this localhost request, what you're going to see is the HTML that our server actually sent back. You can see that it sent back H1, and it says hello from the server side inside of there. All right, so we've seen a very basic example of server-side rendering. However, at this point, our server is still just rendering a basic HTML element in JSX instead of our actual React app. Obviously, now that we've created this app and our page components, we're going to want to have our server render those. So in order to get that working, there are a few steps that we have to take. The first thing we have to do is build our React app, and we can do that by running the command npm run build. And what that will do is generate a build directory that will contain all of our minified, transpiled React code. And now that we've done that, let's open up our server.js file again, and we're going to add a few things. The first thing we're going to add is a line that tells our server to statically serve the files inside that build folder. So to do that, what we're going to do is say app.use, and then express.static. And the argument here is going to be ./build. So we're telling it to serve static files from that directory. And we're going to add an argument here, which is an object that contains the property index and the value false. Basically, if you take a look inside this build folder, you'll see that it contains an index.html file. Now, just by default, when Express is serving a static folder like we are here, when it sees that the folder has an index.html file and the user is trying to load data from it, it will immediately send back that file. So we don't want that to happen for reasons that I'll show you in just a minute. So that's why we specify this index false thing. So now that we have that set up, we should be able to render basic components from our React application. Let's start off by rendering our home page. What this is going to look like is we're going to import it. We'll say import home from pages/home. And then we're going to remove this h1 heading and put in our home component. All right. So now, just to make sure our app is running again, let's say npx babel-node server.js. And if you want this to automatically update for you, you can say npx node daemon --exec npx babel node server.js. Kind of a long command, but that basically just takes care of restarting our server for us as we make changes. Oops, and it looks like I need to add source/pages/home there. And we should see that our server is successfully listening. So let's go back here and refresh our localhost 8080. And we should see that the home component is now displayed in our browser. So at this point, we're able to render basic components from our React app on our server. So the next thing that we're going to do is render our app component. You may have wondered why we didn't do that at first, and that's because in order for it to work, we have to set up routing on our server for the front end. Now this is going to look a little strange. What we're going to do is we're going to have to import something called static router from React Router DOM. Static router is basically the server-side equivalent of browser router that we saw on the front end. So here's what it's going to look like. We're going to say, inside our render to string, we'll say static router, and we're going to need to also pass a prop called location, which is going to be equal to request.url. That just lets this static router know what route the user is actually requesting, so it can render it accordingly. And then inside of here, we're going to display our app component, which we'll need to import up at the top here. We're going to say import app from ./source/app. And then what we're going to need to do is go over to our app component and move this browser router out into the index.js file. So we're going to remove those from here. We're going to have to replace them with React fragments, like this. And then up here, we'll remove that import. And then let's go into index.js, and here's where we're going to add the browser router component. So we're going to say import browser router from React router DOM. And we're going to wrap our app component here in a browser router. So you might be wondering why we have to add this browser router thing to index.js. After all, if our server is just taking care of rendering React for us, why do we need this index.js file at all, right? Isn't it just kind of redundant since we're just getting a pre-rendered HTML document? Well, the responsibilities of this index.js file are going to shift a little bit. So first of all, what we're going to do is change this from React DOM.render to React DOM.hydrate. Now, what React DOM.hydrate does is it takes the pre-rendered HTML that we're going to get from our server and adds React to it so that it will update appropriately when data in our application changes, right? So basically, even though we're getting an HTML document from the server, we still want it to behave and re-render like a React app, right? That's what this hydrate function makes sure of. So now that we have that, the last thing we need to do is inside our server.js file, instead of just sending back this basic HTML string that we coded out, we're going to actually load the index.html file from our build folder and manually replace this div ID root with our React app. Again, the reason that we have to do this is that if you look at index.html, it's kind of hard to see, but basically when we build our React app, it adds these script tags to the end with a random hash that will basically point to the compiled React scripts. Now, since we can't know what these are going to be on our server, we won't know what names they have, we simply have to load this index.html file and manually replace this div with our app. So don't worry if that didn't quite make sense. You're going to see what that looks like here. The first thing we're going to do is load that index.html file, which will say const, and we'll call it template file, equals path.resolve ./build/index.html. So we're loading that file, and up at the top, we're going to have to import path and fs. So we'll say import path from path, import fs from fs. All right. And now that we've resolved the path, we can load the data. So we'll just say fs.read file, template file. We're going to say UTF-8 is the encoding. And our callback here is going to have error and data. Data, of course, here is going to be the actual contents of the index.html file. So what we need to do is basically we'll want to check if there's an error. Hopefully there won't be, but it's just good practice to do something in this case. In that case, we'll just say return response.status 500, and we'll send the error back to the client. We'll just say .send and send the error back to them. Otherwise, what we're going to do is send them back the contents of this template file with the div that we would normally render our React app into, replaced with our already rendered React app. So here's what that's going to look like. We're going to say return response.send, and we're going to say data.replace, and we're going to replace the div with the ID of root. right? It just looks like that if you take a look in the index.html file. We're going to replace that, and we're going to use backticks here because it's a template string. We're going to say div id equals root, insert our React app into there, right? That's our rendered HTML. And that's what that's going to look like. So let's give this a try now. First of all, we need to rebuild our front end since we made changes to it. And then we're just going to run our server again by saying npx node daemon exec. That big long command that I showed you earlier should be in your command history. And let's head over and see if this is working. So let's refresh our app, and we should see that our home page comes up, our about page, our articles page, everything. And if we inspect this, what we're going to see, if we go to network and take a look at the initial file that we got, we should be able to search for server-side rendering example, and we'll see that that HTML is indeed server-side rendered in the first response that we get. In other words, the server took care of rendering all of that for us. All right, so now that we have our app set up for basic server-side rendering, our server is basically taking care of rendering all of our React components. The next thing that we're going to take a look at is how to add styling. Now, this is actually not as trivial as it sounds, since the normal way of adding style to React components in a Create React App application is using CSS modules. Now, in order for CSS modules to work on the server side when we're rendering it, that would involve us setting up Webpack ourselves, and since I really would like to avoid that here, since it can be a little too in-depth and complicated for most people, I'm going to show you instead two of my favorite ways for adding styles to server-side rendering. So the first thing, which is the rather obvious way of going about it, would be to open up the index.css file and simply add all the styles for your application inside of there, right? Basically what happens is that when you build this, here, let's first add just a basic style to it. We'll say H1, we'll say color green, and save it. If we build our front-end application now, if we say npm run build, what we're going to see is that this style that we added is going to be incorporated into the CSS that our app actually uses. So if we open up static CSS, we should be able to find this inside of here somewhere. All right, so there's our color green inside of this minified CSS. So that's one way to do it, and this would work, by the way, if we were to run our application again, just to show you. If we refresh it now, we'll see that our H1s are indeed green. However, there's another, what I would consider better way of doing this, and that's using something called styled components. So basically, styled components are just an alternate syntax for adding styles to our components in React. Here's how they work. We're going to start off by installing the styled components package by saying npm install styled components. And then what we're going to do is, first of all, we'll remove this color green from our styles here. And then inside our app.js file, or wherever we want to add styling to a given element, what we're going to do is import styled from styled components. And I'm not going to go too much into detail on how styled components work here, but here's the basic syntax. We're going to say const, and we'll say big green heading. And then we'll say styled.h1, which will give us the h1 element as a base for the extra styles we're going to add here. And then inside this string, what we're going to do is simply add the styles that we want to apply to this element when we use it in JSX. So what we're going to do is say color, green, and we'll say font size. We'll do something like 96 pixels, just to make it that much more apparent. Now, the way we use this big green heading is simply by replacing the tags of an element with it. And what that will do is automatically apply the styles we specified here and the element we specified here to this element. So in other words, this h1 tag will be a big green h1 tag. We're going to say big green heading. And that's basically it. The problem, though, is that this won't yet work on the server side. I'll show you why in just a minute, but first of all, I'll show you that it works on the client side. If we just run our app as a regular client-side app, we'll see that server-side rendering example is indeed big and green. However, if we build our front end again by running npm run build, what we're going to see is that if we run our server and view that page from there, our server-side rendering example is not actually a big green heading. So what's the problem here? Well, the problem has to do with how styled components and styles in general work. Basically, when we're running it on the client side, styled components work by adding a special class name to each of our components and then generating the corresponding CSS for it. However, when we're rendering our app server side, what we have to actually do is scrape all of the generated styles out of our app and insert them into the index.html file that we send to the client. Again, that might sound a little complicated, but it's actually fairly straightforward. Here's what that's going to look like. The first thing we're going to do is start off by importing something called server style sheet from styled components. And then down here, what we're going to do is have our server style sheet thing that we just imported scrape all of these styles out of our app as it renders, and basically give that to us inside a style tag that we can insert into our HTML. So here's what this is going to look like. We're going to say const sheet equals new server style sheet. And then inside our render to string, we're going to say sheet.collectStyles, just like that. And at this point, this sheet will have scraped all of the styles from our rendered application. So what we have to do now is replace something in our index.html, just like we did with our root. The only problem, though, is that at this point, there is no reliable element that we can replace with our styles. So what we're going to do is inside our index.html file in our public directory, up here in the header, we're going to add 2 curly braces and say styles. Now, the purpose of this is that we'll basically just be replacing this string in our HTML file with our generated styles. So here's what that's going to look like. We're going to add onto the end of our data.replace, we're going to add another .replace, and we're going to say replace double curly braces with styles in the middle with the scraped styles that our sheet object here has. So what that looks like is we just have to say sheet.getStyleTags, and that's really all we have to do. So let's rebuild our front end. Now that we made those changes to the index.html file, we're going to say npm run build, and then we're going to run our server again. And let's go take a look and see if that solved our problem. So let's refresh our app, and we'll see that indeed our server-side rendering example is big and green, and we can see if we inspect the file that we got back, if we open up network, we might need to refresh the page here and take a look at articles. We see that it added this style tag with this randomly generated style name that styled components came up with for us to our HTML, right? So that's basically being applied automatically to all of the pre-rendered HTML inside our application. All right, so at this point we have a pretty fully functional server-side app. Now obviously our app is not that complex. It's only got 3 different pages, and none of those pages displays much data besides a title. But the basic concepts that we've covered here apply in server-side rendered apps of all different sizes. Now, later on in the course, we're going to take a look at how data loading is incorporated with server-side rendering, which is obviously a very important topic as well. But before we move on from the basics, I want to point out a few caveats that have to do with server-side rendering. Probably the biggest thing to keep in mind when you're working on the front end of a server-side rendered application is that a lot of the time the code that you write is not going to actually be executing in the browser. So here's what that means. Let's say that inside your app component, you wanted to access the window global. Let's say that you just wanted to do something like log out the location. So we'll say window.location.href. And let's build our front end and serve it. And what we're going to see is that if we try and load our application again, we'll get an error saying that window is not defined. Now, the reason we get this error is because even though we're used to thinking about our React apps executing in the browser, because we're rendering them on the server, when this code executes, there actually is no window. Now, this is something we'll take a look at in a lot more detail again later on when we look at data loading, but it's very important to be aware of. And another thing to keep in mind too is that if you use document, that's going to suffer from the same thing, right? You're going to get an error generally saying that document is not defined. So that's probably the main caveat to keep in mind when you're working with server-side rendered apps in React, is that when they're being rendered, the code that they're executing is not in the browser. All right, so the next thing that we're going to talk about with regards to software architecture is something called state management. Now, state management is a very important part of virtually any web application, and it can have pretty profound implications on how we actually organize our code. So first of all, let's start off by talking about what state management is exactly. The definition that I've come up with for state management is basically how our application handles the data needs of its components with regards to loading, storing, persisting, and sharing this data. Now, that's a pretty broad definition, and that's by design because the concerns of state management tend to be quite broad themselves. So moving on to different state management technologies, most of you have probably had at least some experience with some of these technologies before. Maybe some of you have heard of all of these. The main state management technologies that we're going to be looking at in this course are the useState hook and context, which are what I refer to as sort of the vanilla React state management tools, right? You don't need to import any other libraries besides React for these. And we're also going to be taking a look at Recoil, Redux, and MobX, which are three of the most popular state management technologies in the React world. Now, before we jump into that, though, I want to point out something that I think of as different sizes of state. Basically, the different state management tools that are available to us work on different scales in our application. So one question that I get quite a lot about these different technologies is how do we choose between them? Well, the main criteria that I look at when choosing a state management tool are the size and complexity of the application that I'm working on. Is it going to be just a simple blog application, or is it going to be a full-scale e-commerce site? And related to this, I also look at how many components are going to need to share the data that our application contains. So is the data that we're loading from the server just going to be used in a single component, or is it going to be used across our entire site? And last but not least, I take a look at the unique strengths and weaknesses of each. This is something that we'll see when we actually implement each of these tools in React. But before we move on to that, let's talk about something that I refer to as different sizes of state. Basically, this idea is related to what I just mentioned, and it refers to the fact that our different state management tools work on different scales in our application. So on one side of the spectrum, we have what I refer to as small state. That is, state that really deals with just very small atomic pieces of data that we want to deal with. And that's usually taken care of by the vanilla React state management tools useState and context. Moving up, then, we have medium state. This is generally state that applies to a smaller subset of the components in our application, but needs to be shared between them fairly regularly. And on the larger end of the spectrum, we have Redux and MobX, which specialize in handling state that is required by a large number of components and is generally part of a large application. And that's basically the spectrum of state sizes. Again, we're going to see how this all applies when we take a look at each of these tools in turn. All right, so the first state management tool that we're going to take a look at is the vanilla React useState hook. Now, most of you are probably already familiar with this useState hook, but I'm just going to implement something here so that we have a good point of reference for the rest of the technologies that we're going to take a look at. So the example that we're going to be implementing here is just a basic counter button that keeps track of how many times it's been clicked. Now, I understand that this is not the most exciting example, but again, it provides a fantastic point of reference for seeing how different state management libraries handle things. So what we're going to do is create a new component inside our directory here. And by the way, you can get this project from the exercise files. It's just a stripped down version of the Create React app without any of the boilerplate code in the app component. So let's create a new file inside our source directory here, which we'll call counterbutton.js. And let's start implementing our component here. So the first thing we're going to do is import the useState hook from React. Remember that since this is just a so-called vanilla React state management tool, we don't need to import any other libraries. And then we're going to define our counter button component by saying export const counter button. And our component's going to be fairly simple. It's just going to contain a paragraph tag that tells us how many times the button has been clicked. So we'll say, you have clicked the button, and we'll insert a value there once we have it, and we'll say times. And then underneath that, we're going to have the button, which will just say click. Okay, so let's wrap both these elements in a fragment. And let's define our state now. Okay, so again, most of you are probably familiar with what this looks like. We're going to say const, and we'll call our state number of clicks. And we'll say set number of clicks equals useState, and the initial value of this state is going to be 0. So all we have to do now is pass this number of clicks state variable inside of here. We're going to say number of clicks times. And for our button, we'll make it actually increment the number of clicks by saying onClick equals, and we'll say set number of clicks to number of clicks plus 1. And that's pretty much all we need to do. So let's display this counter button in our app component. We're going to just import it up at the top. We'll say import counter button from counter button. And down here, we'll display it underneath our state management example heading. So we'll just say counter button like that. And of course, we need to wrap both of these in a fragment as well. Okay, so if we take a look at our application, and you're going to need to run that by saying npm run start if you haven't already, we see that if we click on the button now, it keeps track of how many times we've clicked it. Pretty straightforward, right? Let's just add one more feature to our counter button component. We're going to add an input that allows the user to change the number that we increment the count by every time the button is clicked. So that's going to be pretty simple. We just need to add another state variable, and we'll say const. We'll call this state variable increment by and set increment by. And the default value for that is going to be 1. Okay, and then above our button, we're going to add a label here. Inside there, we'll say something like increment by, and we'll have an input that keeps track of this increment by variable. So this input will have the value equal to our increment by state. It'll have an onChange function that basically sets the value of increment by to the value in the input. So we'll say set increment by to e.target.value, and we're going to need to convert that to a number as well in order for this to work properly. So we'll say number like that. And last but not least, we just want to set this to a number input. So we'll say type equals number. All right, and other than that, we just need to change our buttons on click method to say number of clicks plus increment by. And we should be good to go. So let's give this a try. We're going to say click, and we see that it increments it by 1. And if we change this to another number like 5, we'll see that it increments it by 5 instead. So that's how to create a basic counter button component using vanilla React's useState hook. And again, this isn't the most exciting example, but it's going to give us a great jumping off point for the rest of the technologies we're going to be looking at. Okay, so the next state management tool that we're going to take a look at is context. Now, before we start looking at how context works, let's take a look at why it exists in the first place. Context exists to solve one of the main problems with the useState hook, and that is, how do we let our components share state without having to pass the data around as props all the time? So in other words, if we wanted our counter button to share state with some other component, let's say that we wanted to have two counter button components in our application and have them share their state, what we would have to do is actually lift this state up into the app component, or whatever the parent component of both our counter button components were, and then we'd have to pass down the state as well as these set number of clicks functions as props to each of our counter button components. Now, if that sounds like a little bit of a hassle, it often is, especially when you have to pass those props through several layers of components. This is something that's become known as props drilling. So basically, the point of context, and what we're going to take a look at here, is that it allows components to share state without having to basically pass that state as props. So let's take a look at what context looks like, but first, let's remove these useState hooks from our counter button component. We're just going to get rid of them and get rid of this. And there's going to be a few errors for now, but we'll come back and correct those once we implement our context. So the first thing that we need in order to implement our state as context is a context for the given piece of data that we want to implement. So what we're going to do is create a new file, which we'll call countercontext.js. And here's what this is going to look like. We're going to say import, and we're going to import something called create context from React. So context is another vanilla React tool. And we're just going to say export const counter context equals create context. All right, so that's all this file has to look like. Basically, what our components are going to be able to do later on is import this context and get its current value. So now that we have the context, the next thing we're going to need is a provider. A provider basically defines a section of the DOM where the components inside of it will be able to access a given value for the context. So let's create a new file, which we'll call counterprovider.js. And our provider is going to be its own component. So what we're going to do is we're going to say import useState from React. And we're going to say import countercontext from countercontext. Now, it might seem strange to you that we're importing useState into our counter provider, but this is actually necessary most of the time when we're dealing with providers and context, right? Basically, we're going to use useState to keep track of the current value of our count, and the provider basically just allows the components inside of it to access that value. So let's define our component now. We're going to say export const counter provider, and we're going to say children. We're going to get access to the children prop here. And what we're going to do is say const number of clicks and set number of clicks equals useState, and the initial value there, of course, is going to be 0. So let's also define a function for incrementing this number of clicks. We'll say const increment equals amount. And inside here, we'll say set number of clicks to number of clicks plus 1. And then what we're going to do is just say return. And we're going to return the counter context's provider. So the context that we created inside of here automatically has its own provider component that we can access. So here's what that means. We're going to say counter context dot provider, and we pass the value to this provider, which is just going to be our number of clicks. Okay, and then we display all of the children inside of it. So what we did inside this counter provider is basically just encapsulated the state of our number of clicks. Oh, and one more thing we're going to want to do is in order to give our components access to this increment function, we have to actually pass that as part of the value as well. So what we're going to do is actually pass an object as the value here with number of clicks and increment. Okay. And now that we have our counter provider defined, we're going to go into our app component and wrap all of our app components that we want to be able to access the value. Generally, that will just be the entire DOM. So instead of having this fragment here, we can just say counter provider. And you can see that it automatically imported that for me up at the top here. And we'll close that tag down here and adjust the indentation. So at this point, we're providing the context to any component inside of this provider that wants it. So what we're going to do is open up our counter button component now and allow it to access the value of that context. So here's what that's going to look like. We're going to start off by saying import use context from React, and we're going to import our counter context. We'll say import counter context from counter context. All right, and now we're going to use this use context hook in conjunction with our counter context to get the current value of this use state hook inside our counter provider. So here's what that'll look like. We're going to say const, and we're going to use object destructuring here to get both the number of clicks and the increment function. And we'll say equals use context and pass the counter context as an argument. Okay. Now we'll get to this increment by thing in a second. Let's just comment that out for now. And instead of calling set number of clicks in our onClick method here, we're going to say increment. All right, so we're just calling that function that our provider gives us. So that should be all we need to do for now. Let's give this a try. Let's click on the button, and we see that just like before, it's keeping track of how many times we've clicked the button. So one last thing that you're probably wondering is how do we implement the increment by thing with our context? Well, basically, all we need to do there is go back into our counter provider and add a state variable for it. So we're going to say const increment by and set increment by equals use state, and the initial value for this will be 1. And then we're going to set this, instead of number of clicks plus 1, to number of clicks plus increment by. And then we're going to pass both the increment by value and the set increment by function to this value as part of the object. So we'll say increment by and set increment by. And then inside our counter button component now, we just have to add increment by and set increment by to our object destructuring here. And now we can uncomment this part of the DOM, and we should be good to go. Let's give it a test. So if we change this to 5 and click here, we'll see that it now increments by 5. Right? And if we change that to another number, of course, it will do the same thing. So one thing that I want to point out about the context here is that you generally want to avoid adding things to it that you don't need. In the case of our counter button here, basically the increment by really should be something that it handles itself, since that's the value of one of the inputs that it contains. In general, we want to make sure that we only put things into the context that need to be shared by multiple components. So what we would probably want to do instead of this is have increment by and set increment by use the use state hook, which we can do fairly simply. We'll just say use state, change this to const increment by and set increment by equals use state, default value 1. And then we just need to make this increment function take an argument that tells it how much to increment the count. So what this is going to look like is we're going to say increment by, and then inside of our counter provider, we're going to remove increment by and make that the argument of this function. So we'll say increment by, and there we go. So now we just need to remove these other two properties from our value. And we're done. Let's give it a test. So we're going to say increment by, change that to something like 4, and click on this, and we see that it works perfectly well. Okay, the next state management tool that we're going to take a look at is called Recoil. Now, Recoil is a fairly new player in the state management world. It was created as a way to help us manage the state of larger applications while still making things like code splitting fairly easy to do. Now, I'm not going to go into too much depth on things like code splitting, but what we are going to do is use Recoil to re-implement our counter button example, and this will allow us to see some of its core concepts. So let's head back to our counter button example. And what we're going to do is rewrite our counter button so that it uses recoil instead of context, which is the last one that we looked at. So the first step in integrating recoil, since recoil is not included by default with the React library, the first thing we have to do is install it. So we're going to say npm install recoil in our project. And once we've installed it, we're going to go into our app component. And part of the way that Recoil works is very similar to how we worked with providers earlier. Basically, instead of having a provider for a single state, we wrap our entire application in something called a Recoil root. So let's start off by importing that up here at the top. We're going to say import Recoil root from Recoil. And then instead of wrapping our entire application in a counter provider, we just have to wrap it in this recoil root component. Okay, so what this recoil root thing will do is it'll keep track of all of the recoil states in our application and allow our components inside of the recoil root to access their values. So we can also remove this counter provider thing for now. So now that we have the recoil root, the next thing we're going to do is create the states for recoil. Now, recoil has two main concepts, and those are atoms and selectors. Atoms are individual values that we want to store in our recoil state. So we're going to create two atoms here. One is going to be the state for the number of clicks. So we'll say counter state here, .js. And we're going to create another one too, that will be the increment by state. So we'll say increment by state.js. And let's start off with our counter state. What we're going to do is we're going to start off by importing something called atom from recoil. This atom is a function that we call to create new pieces of the recoil state, to define new values that we want to store there. And then we're simply going to say export const counter state equals atom. And we pass a configuration object here that's going to contain the key of the counter state. This is basically the string that Recoil uses to store this state behind the scenes. We usually just call it the same thing as what we defined the constant as up here. And then we're going to say default 0. And this is the default value for our counter state. And that's what a basic atom looks like. Let's do the same thing for our increment by state. We're basically just going to copy and paste this into there and change the name of this to increment by state and the key to increment by state as well. And then we're going to change the default value here to 1. Okay. All right, and now that we have those two states defined, basically what this is going to look like is we're going to open up our counter button component. And instead of using the useContext and useState hook, we're going to use a special hook provided by Recoil, which is called useRecoilState. Okay, so what this is going to look like, we're going to say import use Recoil state from Recoil. And then what we're going to do is import those two atoms that we just defined. So down here, we're going to say import counter state from counter state and import increment by state from increment by state. Okay. And the next thing we're going to do is rewrite this use context thing. We're just going to replace it with const number of clicks, set number of clicks, equals use recoil state. And we're going to pass our counter state to this. And what this will do is it'll basically create a state that's very similar to our React useState hook, except it can be shared by multiple components without passing the state as props. So in that way, it's very similar to context. And then we're going to change the set increment by thing to use recoil state as well. And we're going to change that value to increment by state. And then we need to go back and change this increment by thing back to, say, set number of clicks to number of clicks plus increment by. All right, so if we go and check our application now, see if it runs, we should see that if we click the button, it increments it by the correct amount. So Recoil is working behind the scenes now. All right, and let's open up our application. You may need to run it again after installing Recoil. And we should see that this works just like before, except now it's using Recoil behind the scenes. Okay, before we move on from Recoil, there are a few more things that I want to show you that are important to know before using it. The first thing I want to show you is how Recoil allows our components to share state. So before we do that, let's start by deleting some of our unneeded imports here, just to clean up a little bit. First of all, let's imagine that our application has two counter buttons instead of one. Well, with Recoil, these will automatically share their state. So let's take a look at this in our browser. And we can see that if we click on this, it will automatically increment both. And if we change the increment by, since that's using Recoil as well, that will automatically make the exact same change to both as well. Now, this may or may not be what you want, which is why it's important to know that this is a basic feature of Recoil. If we were using the useState hook like we saw before, this wouldn't happen. Now, this can be very useful sometimes if you want to have different components that share the same state, for example. What that might look like is, let's say we had another component called something like display count. And all this did was simply display the value of the button count. All right, so this is going to be a very simple component. We're just going to say import use recoil state from Recoil. And we'll say export const display count. And then we're going to do the same thing that we did before. We're going to say const number of clicks and set number of clicks equals use recoil state. And for that, we need to import the counter state. So we'll say import counter state from counter state and pass that as an argument to use recoil state. All right, and then we just have to say return, and we'll return something very simple. We'll just have a h2 heading that displays the number of clicks. We'll say number of clicks, number of clicks. And let's actually display this component in our app component. So we're going to import it into here. I'm going to say import display count from display count and display it. We'll just display it somewhere else on our page, right? We'll put it up at the top here, maybe. And if we go back and take a look now, we'll see that as the number of clicks changes in our counter button component, those changes are also mirrored up here at the top in our display count component. Now, another thing to keep in mind with our display count component is that we're not actually using this state to modify the value, right? We're only concerned with knowing what the value of that state is at a given point in time. Now, in cases like this, Recoil actually provides us with a different hook called useRecoilValue that only gives us the value of the state and doesn't allow components using that hook to modify the state. So we're going to change this now to useRecoilValue, and we'll remove this set number of clicks as well as these square brackets. And that will simply give us the value of the recoil state. So let's check this, and we see that those two are mirroring each other. So that's the first other thing that I wanted to cover with Recoil. The other thing, I mentioned earlier that Recoil has two main concepts, and that those are atoms and selectors. And so far we've only used atoms. So what selectors do in Recoil is they take the fundamental values that are expressed as atoms, and they transform them in some way or combine them into another value. So in order to demonstrate this, let's say that instead of our counter state simply storing an integer, let's say that it stored the timestamps of when each of the clicks in our application occurred. Right? So what that would look like, our default would just be an empty array. And what this array is going to contain is objects that contain both a timestamp, something like that, and they're also going to contain the amount that the counter was incremented by. All right, so they'll just be objects with those two values. Here's what this is going to look like. We're going to go into our counter button component. And instead of saying number of clicks and set number of clicks, we're going to change the name of this to click data and set clicks data. And increment by and set increment by can stay just as we want them to. So what we're going to be doing now is when the user clicks on our button, we're going to call this setClicksData function in order to add a new timestamp to it. So here's what that's going to look like. We're going to say setClicksData, and we're going to use a spread operator here to get all of the current clicks data and append a new click data onto the end. So what we're going to do is say timestamp, and for that we'll just say date.now, and for the amount we're going to pass the increment by state. All right. The next question now is, how do we actually calculate the number of clicks inside our counter button component? Well, one way we can do this is by simply saying clicksData.length. And let's see if that works now. We're going to refresh this. Oops, it looks like we need to change this display count component before it'll work. We're going to say, I'm going to change this to clicksData. And change this to clicksData.length. The repetitiveness here of having to say clicksData.length gives you a clue into what selectors actually do. So now if we go back here, we're going to see that it works just like before, except that this length property doesn't actually work, because when we say increment by 5, all we're doing is just adding one more click data to our clicks array. So here's what we have to do in order to actually calculate that, right? We could, if we wanted to, actually use reduce in each of these places to get the sum of the amounts in all of the clicks. However, that would mean, again, duplicating that data in multiple components. So what selectors allow us to do is define that logic in a single spot. So here's what that's going to look like. We're going to create a new file, and we'll call this number of clicks selector.js. And then what we're going to do is say import selector from Recoil, and create a new selector by saying export const number of clicks selector equals, and we're going to call the selector function just like we called atom, And it's going to take a slightly different configuration object than what we saw with Atom. It is going to have a key, right? So the key will usually just be whatever name we gave to the selector. So we'll just say number of clicks selector. But then we have a function called get. Now what this function allows us to do is actually calculate a value based on existing values in atoms. So here's what it's going to look like. First of all, this takes an object with a get property that we can use to get the values of other atoms and selectors. And then we're going to have to import the counter state atom by saying import counter state from counter state. And what we can do now is get the current clicks data from that counter state by saying const clicks data equals get counter state. All right, so that's what we use that get function for. Once we have the clicks data now, we just need to sum up the amounts of all of the click objects. So what we're going to do is say const total clicks equals clicks data dot reduce. And don't worry too much about the technical details here if you don't work with reduce very often. All we're going to use it for here is just to find the sum of all of the amounts. We're going to say sum and click. And we're going to say return sum plus click dot amount. And then all we have to do is return this total clicks variable. We're just going to say return total clicks. And what we can do now is inside our counter button, instead of using our counter state and saying clicksData.length, we can use that selector we defined. So instead of counter state, we're going to say import number of clicks selector from number of clicks selector and pass that to use recoil state. We're going to say number of clicks selector. Okay, and then we need to change the length. And we also have to remove this set clicks data. In fact, what we're going to want to do instead is actually use recoil value, since we normally don't want to actually set the value of a selector. So we're going to say clicks data, and we're going to import use recoil value. All right, so we'll say use recoil value. But then we also do need the use recoil state for our clicks data. So what we're going to do is say const, and we're not actually going to need the value of that. And we'll say set clicks data equals use recoil state and pass our, oops, I didn't mean to remove it. Let's just say counter state and pass counter state to our use recoil state. And that should be all we need to do. So let's take a look at our application now and click on it. And because of how we're calling setClicksData, we actually do need clicksData from up here. And come to think of it, a better name for this one up here would just be number of clicks, okay, which we'll change this one to as well. We'll say number of clicks times. And before we take a look at it, we need to change our display count as well. In fact, let's just remove it since we don't need it anymore. We're just going to take display count out. And now if we click on our button, we should see that it works like we wanted it to before. So that's how selectors work in Recoil, and as you can imagine, they can be a very useful tool in making our application state management more robust. Okay, the next state management tool that we're going to take a look at here is Redux, which is probably one of the most popular state management tools, with the obvious exception of useState and context, which are included in the React library. Now, first of all, in order to prevent things from getting too complicated with all the changes we made with Recoil, what I've done is I've reverted the code back to the point that we were at when we first added the counter button with the useState hook. You can find this in the starting state of the exercise files, so you don't need to worry about actually doing this by hand. So before we move on, I do want to point out that what we're going to be covering in this video is just the very basics of how Redux works and how to implement a counter button using Redux. So to begin with, let's install the Redux packages. There are 2 of them. The first one is going to be called Redux, and the second one is going to be called React Redux, which contains the React bindings for the Redux library. All right, so now that we have that installed, let's just run our application so that we can look at it as we make changes. So Redux state management has several key parts, and we're going to create a new file for each of those different parts. The first part of a Redux application are called actions. Now, actions are basically anything that can happen in our application. When a user clicks on a button, when data finishes loading, when data starts loading, any action that could potentially change the state of our entire application is considered an action. So we're going to create actions.js here. We'll come back to that in just a minute. The next part of a Redux application is something called reducers. Basically, reducers tell Redux how the state of our application should change whenever a given action occurs. Again, we'll see what that looks like in just a minute. And the other part of a Redux application is something called selectors, which are pretty similar to the selectors that we saw in Recoil. They take care of allowing our components to accurately get data out of the state, as well as occasionally doing things like transforming it. Okay, so let's go back to our actions. Actions in Redux are basically just JSON objects that contain the type of the action as well as the payload. So here's what they'll generally look like. Let's create an action for when our counter button is clicked. We're going to say export const counter button clicked. And actions, as I said, are JSON objects with a type property, which is just the name of the action. We usually put this in capital snake case, so we'll say something like counter button clicked. And the payload, which contains extra data about the action. So in our case, it might contain an amount property that says how much we should actually increment the counter by. So that's what actions look like. Let's move on to reducers. Reducers, as I said before, tell Redux how the state of our application should change when a given action occurs. Now, reducers almost always take the form of functions. So here's what our reducer is going to look like. We're going to say export const, and we're going to give our reducer the name number of clicks reducer. And our reducer functions usually take 2 arguments. The first argument is the current state. So that would be the current number of clicks in our application. And we're usually going to want to give that a default value in case this is the first time the reducer is called. The second argument is the action that occurred. So essentially all of the reducers in our Redux application will be called when any action occurs. So here's how we tell Redux how to change the state when a given action occurs. Basically, what we have to do is return the new state that Redux will care about. So if we just wanted to say return state in here, then that would mean that no matter what action occurred in our application, the state wouldn't change, since whenever an action occurs, we're just returning that same state over again. What we'll generally do is we'll want to get the type of the action that just occurred. So we'll say something like const type equals action. And then we'll want to use a switch case statement on that type. So we're going to say switch type. And then we'll have cases based on that type. So what we're going to want to do is come up with a list of the different actions that this reducer actually cares about, right? In other words, what actions will actually cause our number of clicks to change? In our case, there's only one action to choose from, and that is in fact going to change the number of clicks. We're going to add this counter button clicked string as a case here. And if that happens, what we're going to do is we're going to say return state plus action.payload.amount. And that'll basically add the amount of that action to the state. And of course, we usually need to have a default case here, which will simply return the state, since as I said earlier, every reducer in our application is going to be called whenever any action is triggered. So that's what our reducer looks like. It's pretty simple for now. Obviously, these can get a lot more complex as your applications get more complex. So let's move on now to our selectors. Selectors, basically all these do is they tell our components where in the state to find a given value that they're looking for. So we're just going to have one selector here for now, and that's going to be the number of clicks selector, which we'll call get number of clicks. All right. And what this does is it takes the entire Redux store as an argument, right? So the entire state of our application as an argument, and again, tells our components where to find that. So what we're going to do here is say state.number of clicks. I'll show you how the number of clicks gets there in the state in just a second. So at this point, we have our actions, we have our reducers, and we have our selectors. So the next thing we're going to do is create our Redux store. So here's what that's going to look like. We're going to create a new file here called store.js. And we're going to import a few things up here at the top. The first thing we're going to do is import something called create store from Redux. And we're also going to import something called combine reducers. All right. Next up, we're going to import our reducers by saying import all as reducers from our reducers file. All right, so this imports all of the exports from that file as an object. And next up, we're going to create what's called our root reducer. This is basically where we define how each of our individual reducers fits into the overall state of our application. So here's what it's going to look like in our case. We're going to say const root reducer equals combine reducers. And then we pass an object to this reducer that basically maps the names of our data in the Redux store to the reducers that we defined in our reducers file. In fact, just to make this a little more clear, instead of importing all the reducers, let's specifically import our number of clicks reducer. Then we're going to pass an object to combine reducers, where we'll say number of clicks. So that's the key in the state that the value of our number of clicks will be stored at. And then we tell Redux that we want the number of clicks reducer to be the reducer that will manage that part of the state. All right, now that we have our root reducer, the only thing we have left to do is say export const store equals create store and pass our root reducer to it as an argument. And that's how we create our Redux store. So now that we have the store, which is going to contain and manage all of the data for our application, what we're going to do is open up our app file and add the Redux provider to our application. This is very similar to what we did before with both context and recoil. So here's what that's going to look like. We're going to say import provider from React Redux. And then down here, we're going to wrap basically our entire application, which isn't very big right now, granted, in this provider. So our entire application will have access to the Redux store's state. And then the only other thing we have to do is import the store that we created in our store file. We're going to say import store from store and pass that as a prop to this provider. So we'll say store equals store. Okay, and that's all we have to do now. So let's add our counter button back to our app component here. We'll say counter button. We're going to have to import it up here as well. We'll say import counter button from counter button. So how do we actually access the values now inside our Redux store as well as dispatch actions from our components? Well, we do those using two special hooks provided by Redux, and those hooks are called useSelector and useDispatch. Let me show you how both of these work. We're going to say import from React Redux. And then instead of having this number of clicks use the useState hook, we're going to say const number of clicks equals useSelector. And then this useSelector hook expects a selector, that is a function that takes the state and maps it to a value as an argument. And as it happens, we created our selector earlier, so we just need to import this getNumberOfClicks selector and add it to our counterbutton component. So let's import it. We're going to say import getNumberOfClicks from selectors and pass that as an argument to our useSelector hook. So getNumberOfClicks. So that's how we get the number of clicks from our store. The question now is, how do we actually dispatch this action, right? This counter button clicked action that we created in order to increment the state. Well, the way that we do that is by importing that action. We're going to say import counter button clicked from actions. And then we need to use this useDispatch hook to basically get access to a function that will allow us to trigger this action in a way that Redux will know about it. That might sound a little confusing, so let me just show you what it looks like. We're going to say const dispatch equals useDispatch. And then in order to trigger this counter button clicked action, what we have to do is down here in our button, instead of calling setNumberOfClicks, which no longer exists, we simply say dispatch counter button clicked. And that will basically trigger that counter button clicked action in our application. Redux will pick it up. It will call the corresponding reducers, which will change the state. And that's about it. Let's head over to our application now and see if this works. We're going to click on the click button here. And sure enough, we see that our application is still working, except now it's using Redux behind the scenes. So how do we implement this increment by thing now? Well, this actually gets a little bit more tricky because our action that we defined has the amount hard-coded. As it happens, what we can do with Redux actions is we can convert them into functions. We usually call these action creators when they're functions. And basically, we can pass in any payload that we want to be included on the action as an argument. And because of ES6 syntax, we have to wrap these in parentheses now. So now what we can do, now that this is a function, we can pass in the amount from our counter button. So instead of just saying dispatch counter button clicked, we say dispatch counter button clicked and pass the increment by as an argument. All right, so it should work just like we want it to now. Let's refresh our app. Set this to something like, we'll do 7. Click it, and we see that it increments just as we want it to. Now, obviously, this is just a very brief introduction to what Redux is capable of. You could obviously add a lot more actions here and have a lot more reducers that kept track of different parts of the state. One other thing to notice is that in our counter button, we're still using the useState hook to keep track of the increment by state variable. Now, you could move this into Redux, but what I've found is that it's generally much better if you only put things in the Redux store that you really need in many places in your application at once. In other words, this increment by would really just make things like your reducers, your actions file, and so on more complicated. All right, so let's move on to our final state management tool, and that is MobX. So MobX is another state management tool that I would say is just as good as Redux for managing larger application states. So let's see how it works. Now, as with Redux, we're going to start with our application at the point in time right after we created our counter button, just using the useState hook, right? So we've got our counter button, we've got our app, but there's nothing else to complicate adding MobX to our application. So let's start off here by installing the MobX library. And to do that, we're going to say npm install MobX and hit enter. And now that we have it installed, let's see how to add it. So we're just going to run our application here so that we can see the changes as we make them. Now, one of the things that people like about MobX over Redux is that it's got far fewer moving parts, so to speak. That is, where Redux has actions, reducers, selectors, etc., MobX is much more straightforward. To see what I mean by this, let's create a new file here, and we're going to call that counter.js. Now, what this counter thing is going to be is a class that we're going to use to store our state. This is just kind of how MobX likes to do things. It prefers to use more of an object-oriented approach than a functional approach like we did with Redux. So the first thing we're going to do here is import something called makeObservable, something called observable, and something else called action from the MobX package. You'll see how we use these in just a minute. And the next thing we're going to do is create the counter class that's going to store the state of our counter. So let's say export class counter. And this counter class is going to have a member variable called number of clicks, which we're going to set equal to 0. This is going to store the state of the number of clicks for our counter button. The next thing we're going to do here is define a method, and this method we're going to call increment. Maybe you see where this is going. And it'll take an argument called amount. And inside that method, we're going to say this.number of clicks plus equals amount. So this increment method then is what our components are going to be able to use to change the value of our number of clicks state. All right, and other than that, the only thing we have to do is add a constructor for our counter, which is going to look like this. We're going to say constructor. And inside this constructor, we're going to call this makeObservable function. We're going to say makeObservable. And we're going to say this. And we'll tell it about the number of clicks member variable, which we're going to say is an observable property. And we're going to say increment, which is an action. So what we're doing inside this makeObservable function here is we're basically telling MobX that, first of all, our number of clicks state should be observable, which means that it will automatically re-render React components. Now, this wouldn't happen if you were to just create a basic class and try and use that as a state, so that's what this makeObservable thing does. And the other thing is this increment method, where we're saying that it's an action. MobX also defines something called actions like Redux does, except actions in the case of MobX mean that we're actually calling a method of our state. So that's all we have to do to set up our counter state. Let's save this. And the next thing we're going to do is go into our app component, import this counter that we just defined. We're going to say import counter from counter. And then, before we define our app component, we're going to actually create an instance of this counter class. So what we'll say is const counter equals new counter. All right. And then what we're going to do is pass this counter as a prop to our counter button. So what we'll do is say counter equals counter. And then we're going to go into our counter button class and add that as a prop. We'll say counter. And we can delete this number of clicks state. And instead, we're just going to say counter.number of clicks. Okay? And when we set our number of clicks, what we're going to do instead is simply say counter.increment and pass the increment by state as an argument. All right. Okay, and now in order for this to work, we have to import something else called observer. And this observer thing, which we'll see in a second, is actually imported from a package called MobX React. So just like Redux had both a basic Redux package as well as the React bindings for Redux, MobX also has a MobX package and a MobX package which contains the React bindings. So let's say npm install, and this package is going to be called MobX React. There's also one called MobX React Lite, which contains a much more slimmed down version of that package. Why don't we just install that one? Okay, and now that we've installed that, up at the top of our counter button, let's say import observer from MobX React Lite. All right, and then what we have to do is we have to wrap our component in this observer thing when we define it. And what that will do is it'll make sure that our component re-renders at the right times when the state of this counter changes. So one thing to keep in mind here is that if you forget either this observer thing on the component or this make observable thing in the constructor of our state, MobX will look like it's not working, and that can be kind of hard to figure out sometimes. So make sure that you use both like that. All right, so now that we've done that, let's start our app back up and check it. All right, so what we're going to see is that if we click on this button now, we'll see that our application works just like it did before, except obviously now it's got MobX doing the state. One other thing that I want to point out is when we create this new instance of our counter class and pass it to our counter button, that might seem a little strange to you. After all, if this counter state were needed somewhere way down in the component tree, we would basically have props drilling all over again as one component passed it to another, to another, to another. So one thing that you can do with these instances is you can actually use context to make it so that components can access them without having to receive them as props. Now I'm going to leave that up to you as an exercise, but basically you just need to combine what we learned here with what we learned about context earlier, and have a context that makes this counter instance available to any component that needs it. Okay, so the next topic we're going to take a look at is the topic of data loading. And to make things interesting, we're going to look at how data loading works with regards to server-side rendered applications. So first of all, we're going to want to open up the code at the point that it was at the end of the chapter about server-side rendering, right? After we added styled components and all that. If you don't have this, feel free to open up the starting state of the exercise files and make sure you run npm install to install the dependencies. So with server-side rendering, when we talk about data loading, things can get pretty interesting. And to show you what I mean, let's add some articles to our server that our articles page here can load. So here's what we're going to do. We're going to open up our server.js file. And we're going to add a special API route that our front end will be able to use to load the articles data. So what we're going to do is say app.get. We're going to have the route here be /API/articles. And basically what we're going to do is just send back some fake articles that we'll define here in an array. Normally you'd want to read these from a database, but just for simplicity's sake, we'll define them right in our source code. So we're going to say const articles, and our articles are going to be an array of objects with a title property, for which we'll just put article 1, article 2, article 3, etc. And they'll have an author property, which we'll just put some random names here for. All right, so we'll define a few of these. We'll say article 2, author, Betty. And we'll have article 3 here. And the author for that will be Frank. Feel free to pick whatever names and titles you want. So now that we have our articles, what we're going to do in our articles route here is simply send that back to the client. Now normally this would be where you'd read from the database. So just to make this a little more realistic, I'm going to say const loaded articles equals articles. This would normally, again, be a database call. And then we're going to send those loaded articles back to the client. We're going to say res.json loaded articles. Okay, so our front end now will be able to load the articles from this API route. So let's open up our articles page. And here's what that's going to look like. We're going to import the useEffect and useState hooks. So we'll say useState useEffect. And we're going to say const articles set articles equals useState. And the initial state for our articles, we'll just make that undefined. And then what we're going to do is we're going to load our data inside a useEffect hook Chances are you've done this before in React, so I'm not going to explain it too much. We're just going to say fetch /API/articles. And since this is a promise, we can say .then. If you want to use async await instead and you know how to convert that, go ahead and do it. We have our response here now. We're going to return that and convert it to a JSON. So we'll say response.json, which itself is a promise. And then we're going to say .then. And we'll set the articles to the data that we got back from the server. Set articles data. And we only want this useEffect hook to be called when our articles is first mounted, so we'll just pass an empty array as the dependencies for this useEffect hook. Okay, and then to display our articles, we're just going to say articles, and to make sure they exist before we display them, we're going to say articles and articles.map. And for each article, we're going to display it like this. We'll have a div with a key, which will be equal to the article's title. Inside that, we're going to display the article's title in an h3 heading, so we'll say article.title. And underneath that, we'll display the author of the article by saying paragraph by, and then we'll insert the article's author by saying article.author. And then we just need to wrap these in a React fragment. So let's build our front end by saying npm run build. And then we're going to run our server with the same command that we've used before. All right, so let's load our app again. And what we're going to see is that if we go to the articles page, our articles are all there. However, if we inspect the HTML that we got back from the server, what we're going to see is that it does not actually include the articles, okay? So if we search for the title of one of our articles, for example, such as article 1 in here, we're going to see that that doesn't exist. So basically what's happening is the server is server-side rendering the front end except for the parts where we need to load data. Now, as I mentioned when we first talked about server-side rendering, one of the main benefits of server-side rendering is that it shortens the number of round trips from the front end to the back end. So we're going to want to alter this in a way such that when our server renders our app, the server is the one that loads that data as well. In other words, our front end doesn't need to make those server requests. So in order to have our server be the one that loads the data for our application instead of our front end, there's a few changes we're going to need to make. The first thing we're going to need to do is go down to where we actually render our app, and we're going to need to load the data here. Now, loading the data in our case is going to be fairly simple. Since we're on the server, we have access to the data that the server contains, right? And if this were in a database, our server would be able to communicate directly with the database instead of having to make its own API request. So here's what this is going to look like. Inside where we say fs.readFile and insert the rendered app into the HTML, what we're going to do is load the data for the articles. Again, just to make this a little more realistic, I'm going to say const loaded articles equals articles. This would normally be where we'd connect to the database. And the next thing we need is some way to pass these loaded articles to our rendered application. Now, there are multiple ways to do this, but the way that I'm going to show you here, just kind of a very basic way, is by adding the loaded articles themselves as data to the HTML document, so that when it gets to the front end, our React app can actually take those directly from the HTML instead of having to make its own request. So here's what that would look like. Inside our data.replace here, right before we have our app, we're going to want to insert a script tag. And inside that script tag, we're going to say window.preloaded articles equals, and then we're going to stringify our loaded articles as a JSON object. We're going to say json.stringify loaded articles. Oops, we don't need those. There we go. It should just say $ curly braces json.stringify loaded articles. Okay, so what this is going to do is once our HTML gets to the client, it's going to set the loaded articles on the window object under a property called preloaded articles, and our React components are going to be able to access it through that window object. Now, you might be wondering how this fits in with what I said earlier about not using the window object when we're doing server-side rendering. Well, in fact, you can use the window object, but you just have to make sure that it's not going to be executing on the server side. And in our case, since we're putting that inside a script tag here, that won't be a problem. It's not going to execute till it gets to the client. So that should be all we need to do on the server side for now. What we have to do now is go to our articles component and make it so that our articles component can load the data from the HTML document instead of from the server, provided, of course, that it is actually on the HTML document. So here's what this is going to look like. First of all, with our useState hook here, we're going to set the initial state to window, and we're going to check, of course, if the window exists. And if it does, we're going to check also if the preloaded articles exists on the window. All right? So basically what this will do is if there's preloaded articles, it will set that as the initial value for the state, and we won't have to do anything. So now in the useEffect hook, what we're going to do is we're going to say if window and not window dot preloaded articles, right? In other words, if the window exists and there are no preloaded articles, then in that case, we want to load the articles from the server. And just to make this a little more visible, let's add a console.log statement here, which will say something like no preloaded articles found, loading from server. This will allow us to see where on our server or on our front end, our articles component is actually loading the data. And that should be all we need to do on our front end. One last thing that we need to change is that right now, even trying to see if this window thing exists will throw an error on the back end. So what we need to do here is go into our server and add a fake window global to it. So we're going to say global.window. And we're going to set that equal to just an empty object. That will stop us from getting the window does not exist error. All right. And that should be about all we need to do. So let's, again, build our front end. We're going to say npm run build. And you could create an automated script for this that would automatically watch and rebuild your app for you if you wanted. But we're just going to keep building it manually for now. And then we're going to run our server with the node daemon command. And let's now check our server-side rendering example. So what we're going to see if we refresh our page is that the articles don't even flash, and that's because our articles page isn't actually loading them. If we take a look inside our HTML that we got back, and let's do a search for preloaded articles, we're going to see that our server added this as a script before it rendered our React app. So what our articles page is able to do is just reach into this preloaded articles property on the window and get those articles instead of having to load them from the server. So this cuts down drastically on having to actually load data from the server. One thing to notice, however, is that the server is still not actually rendering our articles page with these articles info, right? It's not until our app actually gets to the user's browser that these things are re-rendered by the front-end React when it calls react-dom.hydrate. In order to do that, we're going to have to make our code a little more complicated. So let's take a look at how to have our server actually take care of rendering the data that we've loaded here, instead of just placing it in the HTML and having our React app render it after it gets to the client. The solution that we're going to be using here involves using context, which we learned about previously. Essentially, what we're going to do is use context in order to communicate between our front end and our back end while on the server side. Before we move on though, I think I should probably point out that the reason we have to do this in the first place is that the useEffect hook inside our components will not be called when our components are being rendered on the server side. That's just how it works. So basically we need to figure out a different way for our components to get their data when they're being rendered on the server. And as I mentioned, we're going to be using context for that. So the first thing we're going to do here is create a new context. And that context is going to be called initial data context. Okay. And inside here, we're going to define our context by saying import React from React. And then we'll say export const initial data context equals react.createContext. And we'll pass an empty object as the default value for that. Okay, so that's our initial data context. The next thing we're going to do is actually import and use this initial data context on our server. So let's open up our server.js file. And up at the top here, we're going to import initial data context from initial data context. And then what we're going to do is we're going to provide this context to our application as it's rendering. All right. So what this is going to look like is around our static router, we're going to say initial data context dot provider, and we'll put our app that we're rendering inside of there. Now, in order for our server and our front end that we're rendering to communicate through this provider, what we're going to do is create an object here. We're going to say const, we'll call it context obj, and we're going to give it a few properties. You'll see what these actually do when we use them. So the first property is going to be is server side, and we're going to set that to true here. We're going to create another property that's underscore requests, which is going to be an empty array. And we're going to have another property that's underscore data. That's going to be an empty object. So here's our strategy here, and it might sound a little strange at first, but it will work. What we're going to do is render our app on the server side twice. The first time we render it, we're basically going to be finding out what components need to load their data on the server side. And then what we're going to do is load that data on our server and pass that data back to our components through the context provider here. That might sound really confusing, so just sit back and watch what it looks like. What we're going to do first is for our provider here, we're going to say value equals context object. And as you'll see, we're going to create a custom hook that our components will use to actually add their data loading needs to this context object, more specifically to this requests property here. Now we'll get to that in a second, but first, after we've rendered our app the first time, we're going to have all of the data loading needs inside this requests property, and all of those data loading needs are going to be expressed as functions. Again, that might sound confusing, but you'll see what that looks like when we get there. So what we're going to do is say await, and we're going to say promise.all. This will execute all of the data needs functions. And we'll say context object dot requests. And because we're using await here, we're going to have to go up here and add async to our callback. And under that, what we're going to do is say context object dot is server side and set that to false. So as you can imagine, our front end is going to use this is server side property to tell whether it's being rendered on the server or not. Our components are going to use that to determine whether or not they should actually make a request to the server or whether they should look in the window object for that preloaded data. Okay, and the last thing we're going to do is delete the requests property. This just gets rid of extra data. We're going to say delete context object dot underscore requests. because we're going to be sending this context object to the client side in a similar way that we sent the preloaded articles. Before we do that, though, we're going to have to render our app a second time. And in fact, when we render it the first time, we don't need to do anything with that HTML. We're just getting the styles and the data loading needs with our style sheet here and our context object, respectively. So let's render it again. And to do that, we can actually just copy and paste this. And say const React app equals render to string. We don't need to collect the styles again, so we can remove that. And everything else is going to be the same there. We're still passing the context object to our provider. And the next thing we have to do is, instead of setting this preloaded articles thing on here, which we don't need anymore, we're going to say window.preloadedData equals json.stringify, and we're going to send that context object along with it instead. We're going to say context object inside json.stringify. All right, the next thing that we're going to do now that we've got our context stuff set up on the server side is create a custom React hook for basically dealing with getting this data out of the context. Right? This will simplify things for our components, since our components will no longer have to care whether they're on the server or on the client side. You'll see what I mean in just a minute. So first, let's create a new file. We'll call this file useDataSSR.js. And here's what it's going to look like. We're going to start off by importing the useState hook from React. And under that, we're going to import our initial data context from initial data context. And then we're going to say export const useDataSSR equals, and this custom hook is going to take two arguments. The first is going to be an argument called resource name, and the second one is going to be an argument called loadFunc. Okay. So the next thing we're going to do is get the current value of our initial data context by saying const context equals use context initial data context. And after that, we're going to create a new state variable for the data that the context contains by saying const data and set data equals use state context._data resource name. So what we're doing here is that context object that we defined inside our server route here with this underscore data property. Basically, what's going to happen is when our components load data, whether they're on the server side or on the client side, they're going to add the results of loading that data to this underscore data property. And after that, they'll be able to access it by using this useDataSSR hook. So the next thing we're going to do is we're going to have our hook check if this code is being executed on the server side or not. Remember that we determined that by using this underscore is server side property on our context. Now, if we are on the server side, what we want to do is add our load function. This load function is basically going to contain logic for loading our data using fetch. We're going to basically push this onto the requests array that we defined inside our context. Don't worry if you're a little confused here. You might have to just walk through the code after we've written it to get a better idea of how it all fits together. So inside this if statement, we're going to say context._requests.push. And then inside this push, we're going to push our load function onto the requests array. And we'll also say .then. And this is where we'll set the result of our data on the context's underscore data property. We're going to say result context._data resource name equals result. So we're setting the result of loading our data on that context's underscore data property. under the name of our resource. So our resource is going to be something like articles or people, or it's just a string representing the resource's name. Okay, the next thing that we're going to do is, if we're not on the server side, then we're going to want to check if the data exists, right? In other words, if we already have the data set in the context on the client side, we don't need to load it. But if it isn't there, then we want our custom hook to actually load it. So we'll say else if data doesn't exist, then we want to load our data and say .then result, and we'll say set data result, and context._data resource name equals result. Okay, so we're just loading the data on our front end if that data hasn't already been loaded for us by the server side. And finally, we're going to simply return that data so that our component can access it. So here's what it's going to look like using this custom hook inside our articles component. We're going to basically delete all of this stuff here, except for where we say fetch. And we're going to import that useData SSR hook that we just created from useData SSR. And then we're going to say const articles equals useData SSR. We're going to pass for the resource name a string that says articles. And then for the load function, our load function is just going to contain this basic console log and fetch. And we can also delete this thing at the end, since we're just going to get the articles straight from this useData SSR hook. We don't need to set them on a state variable or anything. And we can remove these extra imports here. Now, in order for this to work, we are almost there. The last thing we need to do is make it so that this fetch thing will work when it's called on the server, right? So basically on the server, our server code is going to be calling fetch, and obviously fetch is something that only exists by default in the browser. So in order to get around this little detail, we're going to install a package called isomorphic fetch. Basically, this is just an implementation of fetch on the back end. So we're going to say npm install isomorphic, make sure you spell that right, isomorphic-fetch. And then we can use that on our server side by simply importing it up at the top. We're going to say import isomorphic fetch. And that will basically make it so that we can call fetch directly from the server-side code. Oh, and there are one or two more things that we need to do here in order for this to work, I'm remembering. First of all, what we need to do is go into our articles. And the way that the isomorphic fetch package works is we have to actually specify the entire URL when we say fetch. So we're going to have to specify the URL of the server by saying http localhost 8080/API/articles. And we're also going to have to return this promise so that our server will know when everything is finished. And the other thing we have to do is go into our index.js file and add the context provider there as well. So what we're going to do is up at the top here, we're going to import our initial data context from initial data context. We're going to put the provider inside here, so initial data context.provider. The value here we'll get to in just a minute, but let's wrap our browser, router, and app first. Okay, so about this value here, basically what we're going to do is get the value from the window and set it on the context. So we're going to say window and window.preloaded data. Or if that doesn't exist, we're going to have the value of our context here just be an object with underscore data equal to an empty object. Okay? So just kind of a fake version of the normal thing that we're expecting to get from the server. And that should be all we really need to do. So let's try running our application now. And first, we're going to build our front end by running npm run build. And then we'll run our server with the command from before. And let's go check our app. We're going to refresh it, and we'll see that everything is there. All of our articles are there. We can navigate around. And if we inspect the HTML that we're actually getting from the server now, if we take a look at our network tab and refresh it so that we see our initial page load here and take a look at articles, we're going to see if we search for article 1 that yes, we have it as part of the JSON stringify portion when we set it on window.preloadedData, but we also have it displayed in the DOM, which means that the first HTML that our browser is going to see contains these items. So that's good for SEO, and again, it's also much better for user experience. Now again, the code that we wrote here was fairly complicated, so please feel free to look through it once or twice, trace it through with your finger, whatever you have to do to understand how it works, because it's very important to understand how the front end and back end are communicating with each other through context, and also how our custom hook that we created here allows our components not to care whether they're being executed or rendered on the front end or back end. Okay, so the next topic that we're going to move on to here is code splitting. Now, code splitting is another extremely important part of React applications when you want to maximize performance. Essentially, what code splitting means is that instead of delivering all of our React code to the client at once, we deliver it in pieces as needed. What I mean by that is, let's say again that we run an app that has, let's say, 3 pages, right? A home page, an about page, and an articles page. When the client side actually receives and runs that code contains the about and articles page as well. So essentially what we have is just a lot of this code sitting idle that's just taking up bandwidth when the user actually loads our site. So code splitting, again, is a technique that we can use to relieve this problem a bit, and I'm going to show you how it works. So first of all, we're going to sort of rewind the application that we've been working with to back at the point that we were in one of the earlier chapters, where we just have an about page, an articles page, and a home page, and those pages are just displayed on different routes via our app component. You can find the starter code in the start folder of the exercise files. Okay, so to get started, let's imagine that on our about page, we have 3 components. All right, we're going to create those components here inside our pages, and we'll just call them 1.js, 2.js, and we'll create one called 3.js. Now, these aren't overly exciting names, but the point here is that we're going to display these components on our about page and use code splitting to make it so that these components won't actually be loaded until the user visits the about page. So let's very quickly just define these components. These components are simple enough where we can really just copy and paste code from one of our very simple pages and rename it. So we'll make this 1. We'll change this to an h2 tag just so we can tell the difference here. All right, then we're going to copy that, put it inside 2. We'll change this to 2 and 2. And for 3, we'll do the same thing. We're just going to paste it and change this to 3 and 3. All right. So now that we have these components, let's display them in the about page. We're going to import them by saying import 1 from 1, import 2 from 2, and import 3 from 3. And then we're going to display them inside our component here. So we'll say 1, 2, and 3. And of course, we're going to have to surround these with a React fragment like that. Okay, so if we run our application now and take a look at this, we can see that when we go to the About page, first of all, let's open up our inspector window and go to the Network tab just to see if anything new is happening. All right, so first of all, we see that our main JavaScript bundles, all the code for our React application is loaded at the very beginning. And then when we go to the About page, right? Even though we're displaying new components that we didn't need on the home page, we see that there's no additional activity down here in the network tab. So let's change our About page around to use code splitting. What we're going to do here is instead of importing these up at the top, we're going to use a combination of two functions. One is a function that we're going to import from React here, and that function is called lazy. And the other is a function that we can simply use inside our JavaScript files called import. All right, so basically what we're going to do, again, is instead of importing these like this, we're going to comment them out and say const 1 equals, and then we're going to call this lazy function and pass it a callback function that will say import, and then the path to the component that we want to import. Now, one thing to note here is that unfortunately, this syntax only works with default exports. So in other words, while we've said export const 1, right, we've exported our component as a named export, we actually have to say export default 1. And you can leave the named export if you want, but the point here is that we just have to have this as the default export in order for the code splitting to work. So here we're going to say export default 2 and export default 3. Okay, so let's save these files now, and we should be able to use this now. So let's do the same thing now for 2 and 3. We're going to say const 2 equals lazy import ./2, and 3, we're going to say lazy import ./3. And one more thing to note now that we're doing a little bit of code splitting with our application is that when we have components that are code split, like 1, 2, and 3 here, we have to wrap those components in something called a suspense inside our JSX. So here's what this is going to look like. We're going to say lazy and suspense, and we're going to wrap the part of our application that contains these components. So we're going to say suspense, suspense, and put our 1, 2, and 3 components inside of there. So what happens is this suspense thing will actually display a separate DOM element while these 3 components are loading. Basically what's going to happen is when the user goes to the About page now, then our application is going to load the code for these 3 components, but it won't be able to display them until then, so we'll have to display a loading message before that. So for suspense, we can say fallback equals, and then we'll just have a message here that says loading components in a paragraph tag. And again, this will display while our component code is loading. So let's go back to our application, and let's go to the home page and open up our inspector window with the network tab, and we're going to want to refresh this so that we can see exactly what's going on. All right, so we see that we have some bundles being loaded. Now, because we're on the home page and because we're using code splitting, these bundles now won't actually include the code for our 1, 2, and 3 components. To show you this, let's clear our network tab by clicking this clear button up here. And then let's go to the About page. What we're going to see is that our browser loaded 3 more chunks of JavaScript code now, which are going to be our 1, 2, and 3 components respectively, although not necessarily in that order. So that's how basic code splitting works, right? Basically, it allows us to reduce the amount of code that our client side has to load when the user first visits our site, and it allows us to have them load that code only when they need it. And just to show you also, if you refresh the page, you're going to see it flash briefly the loading components message that we had before. Okay, so now that we've seen some very basic code splitting, what we're going to do is take a look at a somewhat more common usage of code splitting, which is to split our code based on routes. So previously, we had these 1, 2, and 3 components that were displayed on our About page, and we saw that when we navigated to the About page, only then did we actually load the code for those components. Now, that's one way of doing code splitting, but again, what we can do is actually split our code based on the different routes. So in other words, we won't have to actually load the code for any of the pages, right? Our home page, our about page, or our articles page until the user actually goes to that page. So let's take a look at how to do that. The first thing we're going to do is go into our pages folder and open up our about, articles, and home pages, and we're going to need to export these as the default export in order for this code splitting to work. Same as we had to do with our 1, 2, and 3 components. So we'll say export default home. Do the same thing with articles, say export default articles. And for our about page, we're going to do the same thing, say export default about. Okay, so the next thing we're going to do is go into our app component. And instead of importing our home, about, and articles pages up at the top here, the normal way, what we're going to do is lazy load them using the lazy function and the import function. So first, let's import lazy. And along with that, as you may remember, we'll also need to import suspense. And then what we're going to do is say const home equals lazy. And here we're going to import our home page. We're going to do the same thing now for the about page. We'll say const about equals lazy. And say import pages/about. And last but not least, our articles page, we'll say const articles equals lazy. And we're going to say import pages/articles. And that's all we should have to do besides adding suspense to our application. So let's go in here and wrap the important parts in suspense. Basically what we'll want to do is wrap our switch component in suspense. This will at least allow our navbar to be displayed before we've loaded our home, about, and articles pages. So we're going to say suspense. And for the fallback prop, we're just going to do something very similar to what we did before and say loading, like that. And just as a side note, you could have a spinner or some kind of better looking element there. But for now, we're just going to have a basic loading message like that. Okay, so that's pretty much all we should need to do. Let's make sure our app is running and go take a look at it now. So let's open up our network tab and we'll go to the home page and hit refresh. So what we're going to see here is that we have this main.chunk.js file, which contains sort of the main React code of our application. But we're also going to see this 6.chunk.js, which is presumably the homepage component up here that's being loaded as a separate chunk. And what we're going to see now, again, if we clear our network and hit one of these, we're going to see, if we go to our About page especially, that we have several chunks loaded. One is the About page itself, and then we also have the 1, 2, and 3 components from before loaded as separate chunks. Finally, if we go to the articles page, we'll see that we get one more. This is presumably 5.chunk.js. So this does call into question how much we should actually split up our applications, and that's going to really depend on your individual use case. Generally, what I recommend is splitting based on the pages that users generally view together and the components that users generally view together. In other words, if we're always going to show the 1, 2, and 3 components on our About page, there's really no point in lazy loading those components, since we're just going to want that to be included with our About pages chunk anyway. However, when there are things on your pages that a significant portion of users won't actually see, for example, if there's a hidden portion that they have to click a button to display, that would be another potential possibility for lazy loading components. To show you what I mean, let's go back to our About page, and instead of just displaying our 1, 2, and 3 components directly, let's have a button that shows and hides those components. So first of all, what we're going to do is import the useState hook up here from React. And then inside our About page, we're going to create a state variable, which we'll call show components, and we'll have one that says set show components. And this state is basically going to be a Boolean. The initial value will be false. It'll be a Boolean that determines whether or not our 1, 2, and 3 components should be displayed. So here's what this is going to look like. We're basically just going to say show components, and then if that's true, we'll render our 1, 2, and 3 components as well as the suspense that surrounds them. Okay? The last thing is that we're going to add a button to our page that will actually change the show component state to true. So we're going to say onClick equals set show components to true, and we'll say show. Okay? So now if we go back to our About page, and we need to set this to a function like that. So now if we go back to our About page, what we're going to see, if we refresh our page and go to our About page here, we'll see that we get our main chunk as well as our chunk 4, which presumably is our About page itself. And if we clear it and click on this Show button now, right? Notice we don't have our 1, 2, and 3 components. If we click on this, we're going to see that only then are the chunks for our 1, 2, and 3 components actually loaded. So that's, again, one possible situation where you would want to do code splitting besides with routing is basically, again, whenever there's a significant portion of code that users aren't going to be seeing. Now, obviously, we've been working with very small components here, but this could apply to components that are much larger and more unwieldy than the ones we've been working with. All right, so there's one more code splitting related thing that we're going to talk about, and that is something called error boundaries. Now, before I talk about what error boundaries actually are, let's discuss one of the problems with lazy loading, and that is that this introduces new possibilities for errors into our application, right? So before, when all of our code was just included in one big bundle, we knew that importing our components like we did up at the top here wouldn't really cause any big problems, because it's all included in the code. So if something went wrong, it was a problem with the code as opposed to a problem with the network. However, now that we're doing this lazy loading thing, we're actually relying on the network to load our components. And what this means is that we very well could end up in a situation where one of our components fails to load and this causes an error. Now, the way that we have it currently, an error in loading one of our components would cause our entire application to crash, right? So if we could load 1 and 2, but 3 for some reason failed to load, these things happen with network requests, then our application would basically crash. So this is where something called error boundaries comes in React. Error boundaries are basically components that block off sections of the user interface that we expect may cause some kind of error. So in the case of our lazy loading here, what we're going to want to do is wrap these components in an error boundary so that if one of them fails to load, we can still see and continue to use the rest of our application. So what do error boundaries look like? Well, inside our source directory, let's create a new file, and we're going to call this file errorboundary.js. Now, error boundaries are just components, and because of a detail that you're going to see in just a second, we have to define these components as class-based components instead of as function-based components. Now, I don't normally recommend using class-based components at all, because primarily you can't use hooks with them, but this is just one of those situations where we're going to have to at this time. So let's define our error boundary component. We're going to first start off by importing React up here at the top, and then we're going to say export default class error boundary extends react.component. Okay, so that's how we define our component. And what we're going to want to do first is define the constructor. All right, so we're going to say constructor props. We're going to call super props. And then we're going to say this.state. And our state is going to be an object with error set to null. Basically, what we're going to do is use this error state to tell whether an error has occurred. You'll see how we actually catch errors inside of here in just a second. So now that we have our constructor, we're going to want to define a method called component.did.catch. Now this is a special method that at the time of this recording you can only use inside of class-based components. And basically it'll be called when an error occurs inside our error boundaries limits. So this method is going to take two arguments. The first is going to be the error. The second is going to be error info. And for now, we'll just print these out. We're going to say console.log error and error info. So that's our component did catch. You can do other things inside of here if you want. You can implement retry behavior, whatever you might want to do inside of there. The other method we're going to implement here is a static method called getDerivedState And basically what this is going to do is allow us to set this error state when an error occurs. So for now, we're just going to say return error as an object like that, and that will convert whatever error occurs and set it as the state for our component. Okay, so other than that, the only other thing we're going to do is implement the render method. And what we're going to do in the render method is basically check if the error state here exists. And if it does, we're going to render some sort of fallback, right? Some sort of error message saying something went wrong with our application. Otherwise, we're just going to render all of the components that are inside this error boundary. So here's what that's going to look like. We're going to say if this.state.error, we're going to say return. And for now, we'll just have some kind of error message. We'll say something like, uh-oh, something went wrong. And you'll probably want to have a more sophisticated component that you display when this happens, but for demonstration purposes, that'll be fine. And then we're going to say return this.props.children if there is no error. So in other words, unless an error occurred, our error boundary, it's going to be as if it didn't even exist. All right, so that's all we have to do for our error boundary. So let's go into our About page. We'll use our About page to test this. And we're going to wrap our suspense in this new error boundary component we created. So let's import it up here. We're going to say import, and we exported it as a default export. So we'll say error boundary from ... error boundary. And we're going to wrap our suspense in that error boundary. Like that. And we'll put all of this inside. Okay. So let's just take a look at our application now. What we're going to see is if we click show, everything works. But what if, for some reason, one of these didn't load? Let's say that one of our components, for example, we'll use our one component. Let's say that one of these components throws an error. We're just going to put the throw directly in the body of the component. We're going to say throw new error help, something like that, right? And it's going to complain that it'll never get there, but we're just doing this to test out the error boundary code. So now if we go back and try and show our components, we're going to see, right, you saw that that thing appeared, and then we see that we got an error. Now, in production, you would not see this error show up. So what you can do if you really want to see what the application would look like with this error occurring is we could create a production build by running npm run build. And then in order to serve this in production, what we can do is say npm install -g serve. That'll install the serve package globally, which we can use to serve our files in more of a production environment. And then we'll just say serve -s build, right? So we're going to be serving the build folder on localhost 5000. So let's open that up. And we'll see now, if we go to the About page and click Show, that we'll see, uh-oh, something went wrong, instead of our application actually throwing an error and crashing. So another thing that we can do with this in our About page, we currently are wrapping all three of our components in this error boundary. And what that means is that basically if an error occurs in one, it won't show any of the others. So what we can do instead is if we want to make sure that the other two show up if one of them fails, or one shows up if the other two fail, what we can do is we can actually wrap each one of these individually in its own error boundary. All right, so let's see what that looks like here. And now, right, if something goes wrong in one, we should still be able to see 2 and 3 show up. So let's see. Let's go back to here. We're going to refresh and click show. Oh, that's because we need to do another production build. So let's say npm run build again. And then we're going to serve it by saying serve-s build. All right, so let's open that up again. Go to our About page, click Show, and we'll see that even though 1 failed to load, we still have our 2 and 3 components. All right, so we've covered quite a few architectural concepts in this course already, and the final one we're going to talk about is how to organize the code in your projects in a way that best suits your overall developer and organizational structure. So to demonstrate this, I'm going to just be using our code from the ending state of when we talked about code splitting. And I'm not really going to be using any of the actual files in it. I'm just going to be using the directory structure to demonstrate a few things. So we're going to talk about function versus feature-based organization in a project. And this is a very important distinction to make. So let's talk about function-based organization first. All right. In function-based organization, let's just imagine that we're building a blog application or something like that. In function-based organization, you have your highest level folders in your source directory based around the functions they provide. So you'll probably have a pages directory as we have here. You may also have a network directory. You might have a util directory for utility functions. And you might also have directories for things like hooks, and if you're using Redux, you might have reducers. So anyway, the point here is that the top level folders in your source directory are based around the functions that those things provide. Now, for some reason, this is the default way of organizing code in most developers' projects. And while it works on a smaller scale, as we move into larger and larger apps, we generally want to move toward feature-based organization. All right, so if this is function-based organization, where we have hooks, network pages, reducers, util, organized around functions, basically. Let's delete all of these, except for pages, of course, to get a clean start. So if we're going to organize our code around features instead of functions, the top-level items in our source directory would be things more like articles, right? You might have signups. You might have subscriptions. You might have, I don't know, competitions, right? Basically, you would be organizing the top-level folders based on what your users would describe as features of your application and not what programmers would normally think of as functions. So the reason that feature-based organization works better, and by the way, each of these folders would usually have all of the corresponding functions inside of it. So in articles, you'd have reducers, components, actions, network, util, etc. And the reason that this works better than function-based organization as you get to larger applications is when you have multiple programmers working on the same code base, they're usually going to be working on it in terms of features instead of in terms of functions. So anyway, hopefully this has been helpful. It's definitely something for you to look into and experiment with. All right, the other topic that we're going to talk about with regards to organizing your code in a project is monoliths, multi-repos, and monorepos. Now, some of you may have never heard of any of these terms. Some of you may have heard of several of them. Let's take a look at the definitions of each of these. First of all, monoliths are projects where all of the source code for that project is in the same directory, the same code base, and these projects generally have to be modified and deployed all at once. In other words, if you have 100 developers making changes to it, you have to keep that in mind because you're going to need to incorporate all of those changes into the next release. Now, if you've never heard of the other two possibilities here, you've probably been working with monoliths for most of your career. So multi-repos are sort of the opposite of monoliths. In a multi-repo, the project's source code is kept separate into multiple code bases, and all of these code bases can be worked on and deployed independent of one another. You may have heard this talked about in the context of microservices before. Now, monorepos are sort of a mix of monoliths and multi-repos. They basically take the best attributes from either side and combine it. In a monorepo, all of your code is in the same code base, but it's organized so that each piece is independent of the other pieces, right? So, in other words, you have the ease of use of monoliths, right? You can just clone and run your project, but you also have the ease of deployment that multi-repos provide. So those are the basic definitions of the three. Let's take a look at the benefits and drawbacks of each. So for monoliths are simple at first. That's why the majority of the time, developers will start off by creating a monolith. It's just usually how it happens. Now, the thing about monoliths, as many of us have found, is that they can become unmanageable if you're not careful. And often, even if you are careful, they still become unmanageable. Now, the reason for this is that monoliths generally work very well with small teams working on projects that are shorter term. So if you're working with 2 other people and you're trying to create a project that's only going to last about 3 to 6 months, or is just a fun prototype, you're probably going to want to stick with monoliths. That's fine. So multi-repos, on the other hand, they do add some overhead for basic setup. You're not going to get your app up and running in a matter of an hour or 2, probably. And multi-repos also contain the possibility that they'll make the deployment process more complex. Now, this may or may not be true. In some cases, they can actually make the deployment process much easier since you don't have to deploy all of your new code at the same time. You can just pick versions of each different feature of your application and deploy those together. And this is what's referred to as independent versioning of different parts, right? So you can have version 1 of the homepage, you can have version 3 of the products page, you can have version 2 of the checkout flow, etc. Now, multi-repos generally work better in companies that have a lot of fairly isolated teams, right? Where the teams don't really talk to each other that much. They talk a lot amongst themselves, but there's not a whole lot of communication. In that case, multi-repos can be quite nice because the teams don't have to sync up their schedules in order to release at the exact same time every week or every 2 weeks or however long. So let's talk about monorepos next. Monorepos, as I mentioned before, include many of the benefits from both of the extremes, monoliths and multi-repos. Now, a key thing to know about monorepos too is that they're used by many large tech companies, including Google, Facebook, Microsoft, Twitter, and many others. So it's pretty clear that monorepos have some pretty nice benefits. Well, we've covered quite a few topics in this course. We learned about server-side rendering in React, as well as some techniques for loading data in a server-side rendered application. We learned several of the state management solutions available for React applications, as well as how to add code splitting to our apps. And finally, we saw some techniques for organizing code in our React applications. Well, now that you've completed this course, you might be wondering where to go next. And my main recommendation would be to try adding the concepts you've learned here to the React apps that you're currently working on. Each of these concepts has the potential of being very beneficial to real-world applications, and this would be a great exercise for you to get some more experience with these concepts.